Okay. So there we go. So we're in 6.3. So we're gonna get through 6.3 and 6.4 for sure. And I think 6.5. We'll see. Yeah, that's the plan. We're looking for a test. Are you looking for a test? In 2 weeks from today. Have you seen the schedule? I'm going to put it off. It was scheduled for, what was it? Tuesday, the 7th of March, a week after next on Tuesday. I want to bump it back to Thursday of that week. So March 9th will be our exam. That's 2 weeks from today. So exam number 2. Well, let me use my better pen. Exam number 2. Thursday, March 9th. So that's 2 weeks from today. We'll take exam number 2. And exam 2, you can tell on the syllabus, or on the schedule thing, it covers 5.2 through 5.4. Right, is that right? 5.2 through 5.4, and 6.1 through 6.6. So we're almost there, in other words, is my point. Today we're going to do 6.3, 6.4, 6.5, I think. We'll see. So we'll only have one section left to go. I mean, we're in really good shape with just 2 weeks, with the 2 whole weeks. You might wonder why I'm doing all that. It's because I am going to be AWOL. And so basically, this section is only going to be, I think it's only 6 problems, right? Or 8. It's 8 problems, yeah. 8 problems. They're all just big old honking word problems. Basically, the difficulty is going to be to set up the word problems. Once we got it set up, we'll just type them into our calculator and boom, it'll solve them for us. So it's all about, this section is all about reading those words and getting those into equations. And once we got that, the calculator is just going to handle it from there. So let's talk about that. So let's go through it. I know this is not always easy. It can be challenging. You drive, rent a truck. 14 million on 260 new vehicles. Each commercial van will cost $45,000. Each small truck $70,000. Each large truck $60,000. Past experience shows that they need twice as many vans as small trucks. How many of each type of vehicle can they buy? Okay. So the first thing to identify is what are my variables going to be? You know, X, Y, Z, or whatever. What are they? Well, you can tell it's because of what they're asking for, huh? In the end, they want to know from us how many vans, how many small trucks, and how many large trucks. So those are our variables. That's our X, Y, and Z. And you can use X, Y, and Z if you want to. I think you might find it easier just to use letters that have meaning for you. So V, S, and L. That way we'll know what they are when we're done. Doesn't matter. We're just going to type it into the calculator anyway. So I think you might find it easier just to use meaningful letters instead of X, Y, and Z. So I'm going to use V, S, and L for vans, small trucks, and large trucks. Now, let's see if we can go through and set up. Usually, almost always, the number of variables will match the number of equations. So if you have 3 letters, you're going to have 3 equations. Now that's the only way you can have one unique answer. If you have like more letters than equations or more letters than, or the other way, if they're not equal, then you're going to get some kind of funny answer, like dependent or inconsistent. The only way you can get a normal answer for everything is if the number of equations match the number of letters. So that's what they're going to do. I think every problem in here is probably going to match that up. So 3 letters, we're looking for 3 equations then from the words, is my point. So we see those 3 letters and go, okay, I need 3 equations. Give me 3 equations out of these words. All right, so they're going to spend $14 million. Okay, there's usually a money equation. And the way the money one will work is it's going to be dollars times one of the letters, in this case, V, plus dollars times S plus dollars times L is total dollars. I'm just giving you the general setup. Pretty much on these 8 problems, there's going to be some variation. But it's pretty common that you're going to have a money equation, which will always end up being money times one object, money times another, money times a third equals the total money. And then you're going to have like a total number of objects, kind of an equation that has nothing to do with money, usually. total objects. This one is no money anywhere. So you're going to have usually, now again, there's variation, but very commonly, probably 5 out of 8 of them, are going to have one that's got money, 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 money all the way across. You know, money next to the letter, money next to the money, you know. The other one that has no money at all. It's just objects, or in this case, cars and trucks and whatever. And then you're going to have a third equation that's weird. The third one, the third equation will be, I'll just call it special. And they'll say something like, something's X is double Y, or something like that. They'll say some kind of special phrase, like, there's got to be twice as many this as that, or 3 times, some kind of special phrase. That's pretty common to what you'll see in these word problems. I'm trying to make it one size fit all. It's not quite that simple, but this is a lot of what you'll see. Okay, so here we go. Do we see a money equation? Let's take all the money numbers. I see a 14 million, I see a 45,000, a 70,000, and a 60,000, right? Those are all money numbers, so they must all be up in the money equation. So we'll say, okay, so that's 14 million. Where do you think the 14 million goes? That's the total money, huh? That's the total money of all their vehicles. It's 45,000. Each van is 45,000. So that would be 45,000 V plus each small truck is 70,000. 70,000 S. I'm running out of room here. Plus, and the large trucks are 60. 60,000 L. See how I came up with that equation? Just money, 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 all the way across. And now, how about the second equation? Yeah, we're using V, S, and L, but yeah, V plus S plus L, and that's the 260, exactly. 260 is the total number of vehicles, huh? See how we grabbed that? Okay, so we've used all the numbers now, haven't we? Every number in the word problem, has been used. I need a third equation, though. And the third one's special. Is everybody okay with those first two? Am I making sense? So the first one's the money, money, money next to the VSL, total money. And the second one has no money at all. It's just total number of vehicles, 260. Now the third one is any kind of special fact they mention. Do you see any special facts? I'm kind of written over the top of it there. But, yeah, right there. Twice as many vans as small trucks. Twice as many vans as small trucks. That's tricky. It sounds like it's not too bad, but it's actually tricky. There's a temptation to write 2V equals S. That's not right. It looks right at first glance because of the way the English goes. Right? It looks like, wasn't that what it says? Twice vans equals small trucks. Not quite. Think about this, and let me put it to you this way. If you want to write an equation, you want to make things equal. You want to make them same, right? If I tell you, hey, this is bigger than this, with my hands. I put this thing up here is twice as big. This one's bigger than this. If you want to make them equal, who do you got to bring up? The big guy or the small guy? You got to bring the small guy up if you want to make them equal. Well, what are they saying? Who are they saying is the big guy? Twice as many vans. They're saying vans is the big guy. There's twice as many. There's like 200 of those and 100 of the other, or maybe, or whatever, There's twice as many vans. So if I want to make them equal, who do I got to double? The small guy. You got to double the other one, huh? It's not the way the language flows. You got to put some more, so it's not that way. It's V is 2S, isn't it? That's the right way. You got to double the small trucks because the van already is twice as many. So if you want to make them equal, you got to double the smaller one, huh? So you can't just take the way the language fools you, the way it comes. You got to give it a second thought like that. Yeah, so we want V equals 2. That's an S. My S's look like 5s. It's still looking bad. Anyway, that's supposed to be V equals 2S there. That's the right equation. Does that make sense? So just remember, you got to double or triple or whatever the small guy. if you want to make them equal, whoever the small guy is. In this case, it's the small trucks. Okay, now, those are my three equations. I'm going to go to a fresh screen and write those again. Is that good? Everybody got those down? Or I'll write them again. So I guess I could just go do that. And then we'll put them in our calculator. So the first one again, what was it? It was 45,000 V plus 70S, 60, thank you, on the L. 14 mil, a lot of zeros. And the second one was just V plus S plus L is 260. And the third one, what was it? It was twice vans, so it's actually twice, or vans equal, that's right, either way, you can write it either way. Vans is twice small trucks, like that, right? There's our three equations. Now, we're ready to go almost. This equation is right, but it's not in the right format for typing it into our calculator. Right, we have to have a zero on the right side, or not a zero. I mean, we have to have the letters on the left side. Right, see how the first two equations have all the letters on the left, numbers on the right? Remember, you have to have it that way for your calculator. When you type into the matrices, got to have all the letters on the left and numbers on the right. So that just means I just need to take that 2s and just jump it over. So I get v minus 2s. In fact, let me just line it up this way. So it becomes v minus 2s equals 0. Does that make sense? I just setting it up in the format for entering it into my calculator. So there's really a 0 here in the L slot also, isn't there? Am I going too quick? Does that make sense what I did there? So we twice as many vans as small trucks, so you got to double the smaller one. Double the small trucks to equal the vans. And then bring it over, because for our calculator, we're going to have all the letters on the left and the numbers on the right. So to bring this over, remember when something jumps over the equal sign, it changes signs. So v minus 2, so we have a v column, an s column. There's nothing, for the third equation, there's nothing in the L, let's put a 0. And then 0 is now on the right side, because there's nothing on the right side either. Type it into your calculator. Now we're ready to go. So now let's just make a big old matrix with, and these are ones, these numbers will be ones, won't they? Right, so type that into your calculator. You know, skip this, this is gone now. All right, type that into your calculator and hit the RREF button. And please tell me what you get. Remember how we learned to do that yesterday? No, Tuesday? Something like that? Yeah, Tuesday? Give you a second to figure that out. Guys getting that? Anybody got an answer there?
160, 80, and 20.
Thank you. 160, 80, and 20 for the, what is it, vans, small trucks, large trucks. Anybody else getting that? Is that coming across okay? With the RREF for those? You guys doing okay? Okay, so Alex took clothes to the cleaners 3 times last month. First what just happened? Hope I did a bad thing. What was that? Did I make something bad happen here? I don't know.
It's showing up on the screen.
Oh, is it fine on the screen? It's weird on my thing. Oh, there we go. Is it all good? All right. I don't know. I'm trying to do something weird. All right. So there we go. Let's read this word problem. So Alex took clothes to the cleaners 3 times last month. First, he brought 2 shirts and 1 pair of slacks. Paid $8.47. Then he did 5 shirts, 4 slacks, and 1 sports coat. Paid $33.90. Finally, 3 shirts, 2 coats. Paid that. How much was he charged for each shirt, each pair of slacks? Yeah. So this is. Shirts, slacks, I'm going to go P for pants, and sports coat, C for coat, whatever you want to use. You can do X, Y, Z if you want. All right, those are my three variables. So I need three equations, right? Think you can write three equations from that? This one's fairly straight ahead. You see what it's saying there? 2 shirts, so 2S, plus 1 pair of pants, and that added up to 847, right? Next equation, 5 shirts, 4 slacks, 5 shirts, 4 pair of pants, and 1 coat, and that added up to 3390. Finally, 3 shirts and 2 coats and 2245. There's my 3 equations. See how I came up with that? Do the RREF now. Put that in as a matrix. Any place that's missing will be zeros, right? Like right here's a 0, right here's a 0. In the matrix, the place is missing. Anytime you have a letter with no number in the front, that's a 1. But if the whole space is just missing, that's a 0. And then you put it into your matrix and do the graphing calculator, RREF. On that. And let me know what you get. We're trying to get the price, basically, for each shirt, slacks, and sports coat.
On your second row, it's 5 shirts, not 4 shirts.
Oh, is it? Did I mess up? Yes, you're right, huh? 5, 4, 1, yep. So, I'm all messed up. Thanks. So try that, and it should work better. Is anybody getting it? Well, what?
For
Go
the
ahead.
first one's $2.49.
Uh huh.
The second one is $3.49.
Uh-huh.
The coats is $7.49.
Great. You guys able to get those answers? Why don't I take a second? All right, so, whoops, did the wrong thing there. So there it is. Basketball team sells tickets, cost $10.20 and VIP for $30. Team has sold 31.34, 61 da 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 da. All right, let me let you try that. I'm going to run through a roll. This is a lot like the truck one we just did, where you're going to have one equation that's money, 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 money. Another equation that's just total objects, tickets in this case, nothing to do with money. And then a third equation that's just like a weird fact, like something's double something or something is, you know. So it's going to be 3 equations, money, 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 money. And then the second one, no money, just total objects. So total money, total objects, and then a weird equation or special equation. So it's just like that. Okay, so one of them is going to be like a money equation. So, and what, there's 3 kind of tickets, aren't there? There's, why don't we just call them X, Y, and Z? X, Y, and Z for the first, second, and third kind of tickets. $10 tickets, $20 tickets, and $30 tickets. X, Y, and Z. All right. So anyway, so the money equation, remember you put the money next to each of these. So 10 times X, 20 times Y, 30 times Z, right? The money, money, money. And what's the total money? Somewhere. Oh, there it is. Yeah, right. 58, 810. So is that good so far? That makes sense on the money equation. That uses all the money numbers, right? Okay, so that's the money one. Now the next one we have total objects. It's just, it's just not worried about their monetary value. Just how many total tickets, right? Just however many total tickets. Does it say somewhere total tickets? That's the 3134. That's just tickets. We don't care about their monetary worth. Is that good? That's just like the small truck, vans, large truck problem, right? So far, right? We have a money, money, money equation. We have a total objects equation, very standard, okay? And then a weird one, a special one. There's always a third one that's special. So what's the special one here? It's this kind of thing. So you see how we've used all these numbers, right? The money, the money, the money, the money, and the 31, 34. The only thing we haven't used is this fact right here. 160 more, 161 more $20 tickets than $10 tickets. Okay, so that's X. No, this is X, and this is Y, huh? We call it, right? So they're saying there's 161 more Ys, aren't they? So what are we going to do? Remember, what happens when they tell you one guy's bigger than the other and you want to make them equal? Who do you got to bring up? The small guy. You got to add to the small guy to make them equal, right? So who's the small guy, X or Y? X, because Y is more. There's 161 more $20 tickets. That's Y. Y is more. So I got to add to X. I got to say X add 161 will then equal Y. Does that make sense? X is the small guy, right? You want to make them equal. To bring about equality, you got to add to the small guy. Those are some people have that economic system in mind, for example, right? Just give to those who have less. Make them equal. Anyway, right? So that's what we're doing. So it's bringing up the small guy, making them equal, right? That's what you do in those. Okay. Is that good there? Now, we have to put that, I don't want to race that too fast. Is that okay? Questions I can answer on that? We have to put it in right format now, right? So which means we got to get the letters on the left, the numbers on the right. So what do? We just jump these guys. Remember, whenever something jumps to the other side of an equal sign, just changes signs in front of it, huh? So that'll be X minus Y and negative 161 on the right side. And the Z spot is just going to be a 0. Am I confusing you? And I'll just get this out of the way. There's my 3 equations. Is that too much of a mess? Is that confusing? Does that make sense? So again, you always add to the small guy when you want to achieve equality, right? So we added to the X because it was saying the Y was more. So I had to add to the X. And then you got to get letters on the left, numbers on the right. So type that into your calculator now. Now we just use the graphing calculator. Remember now the X, Y, and Z in the middle equation, the second equation, there's no numbers in front of those, so what numbers do I put there? Ones, right? Exactly. So there's ones there, and ones down. Oh, the bottom equation has ones also, and a 0, doesn't it? So R, R, E, F, all of that. And we'll try to figure out how many tickets they sold of each type. Give you a second on that one. Am I getting an answer there?
First one's 1,120.
1,120?
Second one is 1,281. Third one is 733.
For XYZ. Anybody else getting those numbers? Get them? So that's X, that's Y, that's Z. That's how many $10 tickets were sold, how many $20 tickets, and how many $30 tickets were sold. Those are the 3 questions they will ask us. Is that good? Is it making sense? The whole calculator thing and the equation writing? Roberto's here. I always like to point out Roberto, our class tutor, right? So if you have any questions leading up to the exam in 2 weeks, Roberto has his hours on the back, and he checks in with us, so he'll show you just like we learn in here and how the practice exam. Yeah, Nicholas.
X, Y, and Z back in, it's off like $20 for the original total.
Oh, are these rounded? Do these round a little bit? Were these answers exact, or were they rounded?
Those are the exact numbers.
Exact numbers? Then it shouldn't be off. Which equation did you plug back into? The top one?
Yeah.
Can you check that real quick? Yeah, check closely. It should only be off a little bit if it was rounded answers. It's not rounded answers, so it should be right on the money. I got it perfect. Okay, so we good there? Shall we move on? Okay, Fran receives 113 per year, simple interest for investing 1,300. Part is invested at 7, 8, 9, 800 more at 9, then at 8. Find the amount invested at 9. Confusing, huh? Yeah. Investing 13, yeah. This is confusing because it's like all money. So it's hard to distinguish when I say like money versus objects because it's kind of all money. So, yeah. Let's just start with the money equation first off. Well, that's hard because everything up there is money. Basically, the difference on this one, the difference you have to distinguish out is interest money versus invested money. There's two kinds of money there. There's interest earned money, and then there's money invested, right? There's what you invest, and then there's what you get back in interest. Those are two different things. So how do we know what's what? Well, 113 is what she gets in simple interest. That's going to be the total for the interest one, right? And we'll call this X, Y, and Z. X, Y, and Z. And that's where we're going to put the percentages, huh? 0.07X, 0.08Y, 0.09Z. Is that good so far? Because that's how you calculate interest, huh? You just take the percentage rate times the amount of money in that account. Now the second equation is going to be like what she actually invests. X plus Y plus Z is what? What did she total invest? That's the 1,300, right? That's saying that's the total amount of money she invested among those three types of accounts. Is that making sense how I'm doing that? And then the third one will be a special. I'll let you try to figure that out. I'll give you a second on that. Give you a second. Try that. See if you can get that figured out. And is that okay in those first two? Is that still making sense in those first two? So the interest equation, and then the money invested equation, and now the special one's over here, this 800 more at 9% than 8%. So same kind of thing. They're telling us that somebody's bigger than somebody, huh? Right? That's pretty much what they always do, right? Or sometimes they'll say somebody's smaller, but same fact said the other way. So they're telling us somebody's bigger than somebody else. What do we have to do to make them equal? We've got to bring up the small guy, right? Got to bring up the small guy. Now, who's the small guy? There's 800 more at 9% than 8%. So who's the small guy? 8%. Is that X, Y, or Z? Y. Yeah, it's Y. 8% is Y. So Y is the small guy. 8% is the small guy, so we got to add to the small guy the 800, right? And then that'll equal the big guy. Who's the big guy? 9, the Z. Does that make sense? See how I added, right? Because there's 800 more at 9%. This is the 9%, the Z. This is the 8%. There's 800 more in the 9%. So that means I got to, if I want to make them equal, I got to add to the one that's smaller. Because the Z is already bigger. He's already 800 bigger. So if I bring up the other guy by 800, then they'll be equal. That makes sense? Getting the hang of writing those special ones a little better. And then we got to put that in the right format, right? Got to get the letters on the left and the numbers on the right. So grab that Z and toss it over, grab that 800. So it'll be Y minus Z is minus 800. Right? Whenever you jump something over the equal sign, the sign in front changes. So we've got it all. Now let me just to clear it up. So we're going to type in 0.07, 0.08, 0.09, 113. That's that first equation. The next one is going to have ones, huh? 1, 1, 1, 1300. And then what about this third equation? He doesn't have anything in the x slot. So that's a 0, huh? 0 and then 1 for y and -1. That's a -1 on z, huh? And -800. There's our matrix RREF, our favorite graphing calculator tool. These are pretty fancy word problems we're solving. Are you able to do more fancy word problems than ever before in your life? That's my goal for you. That through this course you'll climb higher in your math ability. These are pretty fancy ones. I mean, people would be impressed. If you wanted to brag or something, you could show people, I solved this word problem. That's what I do all the time. All right, so what do we got?
100, 200, and 1,000.
100, 200, and 1,000. 100, 200, and 1,000. Good. You able to get those numbers? Making sense how we got those three equations? So the interest equation, the investment equation, and then the special equation, where we add to the small guy to make them equal. No questions? Okay to move on? Okay. Let's take a look. Animal breeder can buy 4 types of food for Vietnamese pot-bellied pigs. Each case of brand A contains 35 units of fiber, 30 of protein, 30 of fat. Each case of B, blah, 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 blah. Each case of C, blah, 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 blah. Each case of D, blah, 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 blah. How many cases of each brand should the breeder mix together to obtain food that provides 45 of fiber, 45, 50 fibers, boom, boom. Wow. This is a mess. And then what's all this words down here? Let X represent the number of A, Y is B, Z is C. I'm reading down here now. And W represents the number of D. Okay. There are 4 ways in which the breeder can mix the brands to obtain the food. Oh, okay. We need to, I didn't realize it does this. All right, let's do it. All right, so basically what we're going to do on this one is we're going to have a fiber equation, a protein equation, and a fat equation. And that's because of these totals down here. And then above, you're going to have like how much brand A, how much brand B, how much brand C, how much brand D, and the total. Make a big table out of it. Okay, so about the fiber, brand A, it says 35 for fiber, so 35X, 30 for protein, 30, whoops, that's supposed to be Y, huh? Well, you don't even need to put in the letters if you don't want to. Who cares? We're just going to go to our calculator anyway, Let's just skip them. 30 for the fat.
Shouldn't those be on the next row?
Yeah. What am I doing? Yeah, right? Yeah, thank you. 35, 30, and 30. Right. Because that's all A, huh? That's all A. I was getting confused. That's all A, so, right? Because that's all brand A. Fiber, protein, and fat. Thank you for A. Right. And then we go on to B. And B is those 3. 140, 90, and 70. Good. And then C is 245, 150, 120. And then D is 420, 270, 200. To obtain food that provides. Okay, and then finally the totals. $45.50 for fiber, $28.50 for protein, and $22.50 for fat. There's our matrix. Just type that thing in. RREF. Now we're going to get something funny, and I want to go through with you what we need to do about that. So let's first get our oh yeah, so we're going to get a whole weird matrix. So I need to get it with you. This whole weird matrix. So let me know when you get it, and then I'll write it on a new screen and we'll talk about it. Because it's not going to be just one clean answer. It's going to be infinite solutions. I think one of your rows will be zeros all the way. Be infinite solutions, and then we need to talk about what that means and how we answer their questions. Because there's actually more than one way to do this whole thing for the old pot-belly pigs. Give you another minute, then I'll write. Did you get a matrix?
Yeah, but I don't know if it looks right.
Oh, yeah, I'm not sure either. Yeah, that's right. Yeah, no, that's good. I was wrong about the zeros thing.
Okay.
Yeah, so let me see. I'll write it over here. See if you guys are getting that same thing. So I bet that's right. Getting 1, 0, 0, negative 1, 0, 0, 1, 0, 5, 15, 0, 0, 1, negative 1, 10. Thank you. So you guys getting that answer? Is that what a couple people getting? Want me to go back to the page? You all able to get that down? You get that typed in? All right, so we get that. Now, what does that mean? Well, remember how to interpret the meaning of these things. Let's go back. Remember, this was brand A, brand B. Remember what the matrix original was, and this is total. Right? So, and this was whatever the three things were. Fiber, protein, whatever. Yeah, fiber, protein, and fat. Okay, anyway, what is this really saying? This is saying that however much, well, let's just take this first equation. You could just put A's. I know they did X, Y, and Z. I'm just going to stick with A. I think A is easier. Why change to X, Y, Z? I'm just going to do A, B, C. Right? It's A's all the way down the first column, B's all the way down, C's all the way down, D's all the way down, right? And then these are equal because they're total. Okay, so what does that first equation say? 1A minus 1D equals 0. Isn't that what that first equation is saying? And what does the second equation say? 1B, couple zeros, 5D, is that an equals 75? What, it looks like a negative sign. So that's equals, right? 70, is that 75? Did you get 75? Oh, 15. It's 15, huh? My equal sign made the top of the 7. I'm getting messed up. So it's 15. Thank you, Roberto. 15 and 1C minus 1D is 10, right? Do I get that right? So I'm just saying, hey, what are those equations saying? Let's change them back to the A's, B's, C's, and D's. That's what they're saying. Now, when they say W is there, they're wanting me to go A, B, C, D. I know they're calling it X, Y, Z, W, whatever, same thing, right? They're saying, look, make W 0. See how they're saying that? Put 0 in the last spot, D. Make D 0. So if you make D 0, don't these just vanish? Am I going too quick? If you make D 0, those drop out, don't they? And so then A will just be 0. B will just be 15, and C will just be 10, huh? See how we're getting that answer? What they're saying is, hey, if you decide to put no whatever brand D is, no D, you do no D, then you got to put no A, 15 Bs, and 10 Cs into their diet to make the right amount of protein, fiber, protein, and fat. So anyway, so my answer is 0, 15, and 10. Going with the W0. Am I confusing you? Does that make sense? So I took this matrix and I wrote these equations. And then I plugged in D is 0, and they just dropped out. Because they gave me D is 0, right? Right back here, they said, let the last one be 0. See right there? Let the D be 0. So I said, okay, I'll plug in 0 for D. They dropped out, and I got A, B, and C. Now, on part 2, they're going to probably make a different number for W. Let's go back. 0, 15. Now they're going to say, let me change my colors. They're going to say, okay, what if you let W be 1? In other words, what if you got something, 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 1? You know, the last spot's 1. Let me make that a little more clear. They're saying number, number, number 1. So now they're saying take these same equations, right? We're still dealing with the same answer matrix, which results in these same equations. That's not changing. But this time, let me go over here. They're going to say, now I want you to plug in the D, right? It's A, B, C, D, right? The D is 1 instead of 0. What if you use 1 unit of whatever that D stuff is? Can you get answers now? Yeah, I can. 1A minus 1 times 1. Plug in 1 for D. So what is A going to equal? A minus 1 is 0. A is 1. So now I'm just plugging in 1 for D everywhere. What about the second one? 1B plus 5 times D. D is 1, they're saying. So that's B plus 5 is 0. So B is negative 5. How can that be? Oh, I was 15, huh? No wonder I'm having trouble. That should be 15 over there. 15, subtract 5, it's 10. B is 10. Am I losing you? So I'm taking these equations, right? First they told me in part A, they said let W be 0. In other words, let D, it's A, B, C, D, let D be, I put in 0. They all dropped off, A, B, C. But then on the second part, they're going to say let W be 1. Let D be 1. 1 and less. So I plug in 1, 1, 1. And just solve for A, B, and C. So I solved for A, came out 1. Solve for B right here, came out 10. And then solve for C. Again, 1C minus 1. Plugging in 1 for D, 10. Ooh. And the C minus 1 is 10. So C is 11, right? C is 11. That's another answer that would satisfy the dietary requirements. And they'll have you do a part 3 and a part 4. They're going to probably make W2 and W3 or something. I don't know. Whatever. Some other choices for W. Does that make sense? You just keep going back to these equations every time. And when they give you a new D value, a new fourth value, you just plug it in, solve for A, B, and C. Is that okay? So see, this problem has more than one answer, doesn't it? It has infinite answers, depending on, there's different ways you can do it to configure the diet and fit the requirements. There's not just one way. Did you notice the number of letters didn't match the number of requirements? Right? 3 requirements, 4 letters. That's why there's not just one unique answer. We good with that? Okay to move on? Okay, let's see. Controller, money manager, small company, puts the money in a bank account paying 3% per year. He uses some additional money amounting to 1/3 the amount he placed in the bank to buy bonds paying 4% per year. With the balance of funds, he buys 9% certificate of deposit. The first year, the investment brings $670. If the total of the investments is $10,000, how much money is invested at each rate? All right. It's like the other investment. You're going to have interest. Well, it's not interest in this case. It's return, whatever. Money made. And then money invested. And then I think we're going to have a special 1/3. So money returned or interest earned or whatever. Money invested. So money made, money invested, and a special. All right, this one looks a little tricky. Let's see what we can do. So a small company put some money at 3%. Okay, 0.03. Let's just call that X. We'll just call these X, Y, and Z, right? There's X here, Y here, and Z here. 0.03X And 1/3, amounting to 1/3 that at 4% bonds. Well, I'm just going to go 0.04y. I'm going to forget about it for now. And the last one is 9% for Z, right? And that total, how much money did he make? He returned $670. So far, so good? It's just like the interest problem so far, right? Just the three accounts make 3%, 4%, and 9%. XYZ, 670 is what they made. That was the return, like the interest, right? Money made. And then now for money invested, X, Y, and Z, what's the total money invested? 10,000. We good so far? So really it's just like that other banking problem, right? So far. We have the three interest rates, total money made, the three investments, total money invested. Now the special. So what's the special?
1/3 of 10,000 was used to buy a bond at 4%.
Yeah, this whole 1/3 thing, huh? That's the only other fact I haven't used. All the rest of the numbers have been used. So, yeah, it says 1/3. 1/3 of the amount placed in the bank. Okay, what does that say? We got to read that careful. Let's see. He uses some additional money, 1/3 the amount put in the bank. Well, the X is the amount in the bank, right? X is the amount, right? Bank X, right? So the bank is X. 1/3 of that amount, 1/3 times that, is the Y. That's what they're saying. So this isn't a bigger, smaller thing. This is a multiply thing. So it's different than the other specials. So the other specials, they told us this is bigger than that one, or this one we had to add to the small guy. This is not an add-subtract thing. There's nothing added there, nothing subtracted there. This is a multiply. 1/3 of. Of always means times. Like if I said 1/3 of you are going to get A's in this class, how many will that be? I would need to take 1/3 times whatever, 30 students or 20 students or whatever, right? Of means times. So you're aware of that in math? So 1/3 of the class, that'd be 1/3 times the number of students in the class to find that, right? So 1/3, so 1/3 the amount in the bank, 1/3 of the bank, 1/3 of the X is the Y. Good to there? Are we happy? Now we got to make that into the right form. It's not in the right form. Letters on the left, numbers on the right. So bring this Y over. It's going to be 1/3 X minus 1Y, no Z, is 0. Does that make sense? Let's type them into our calculator. So we have, these are 1s by the X, Y, and Z in the second equation. Can you type that in and give me the RREF? Reduced row echelon form. So the 1/3, you'll have to type that in just 1 divided by 3 in that spot. Let's see what we get. We're looking for one clean answer because the number of letters matches the number of equations. How we doing? Anybody? You guys getting this okay?
Yeah.
You do the matrices and everything? Good. Okay. Now the 89s, you guys, the 89s over the matrices, okay? Yeah. All right. Anybody got it? 3,000, 1,000, and 6,000. We good? That makes sense then? That's how much he invested in each of the 3 accounts. All right, we better move on. Okay, table on the right shows the calories, sodium, protein, 1 cup of various kinds of soup. How many cups of each kind of soup can we mix together to produce 10 servings of soup? Oh, this is tricky. Let me show you this one. They want 10 servings of soup. That's tricky that they're doing that. Each of which provides 219 calories. So they want 219 to be the total calories, right? See how it's calories total, 219? And 1308 is the total sodium. And 13.6 is the total protein. So it's like a big matrix where we're just going to type in, those are the total numbers on the right, but here's the trick. There's one trick. Other than, that's almost it and type it in and go, but there's one little trick. I wouldn't have thought of it except I looked at the show me help button the other day. Anyway, and what it is, notice what they're saying over here. 10 servings, each of which, So if you want each serving to have, what if I said to you, hey, I want each of you to give me $3 tomorrow. Each of you. So what's the total money I'm going to get? 3 times how many people? Really, nobody would bring us. I get nothing. But anyway, right? So when they say each, they want 10 servings, each one to have 219. Then you got to take 10 times 219. And 10 times those other numbers. We got to add a 0 to the back of each of these numbers. Because it's that many calories for each of 10 servings. That's tricky. I wouldn't have noticed that except for the help button. So you got to add zeros to the back. Well, actually, the decimal is going to become 136, isn't it? Adding a 0 to the back of a decimal doesn't do anything. You move the decimal. So that becomes 136. Is that good? Does that make sense? Because they want each of the 10 servings to have those. So this is now the total for all 10, right? Did I have that right? This problem always confuses me. To produce 10 servings of soup, each of which provides boom, boom, boom. Yeah. So, yeah. Right, table on the right shows the calories, sodium, protein, in 1 cup of various kinds of soup. Yeah, right. Yeah, it's right. This is right. Because basically we're going to say how many of these and how many of these and how many of these making 10. Oh, I need that other equation.
You need to add them up to 10.
I got to add that equation there, don't I? What are we doing? I better read the problem here. Table on the right. Da da da. How many cups of each kind should be mixed together to produce 10 servings? Each of which. Right. So we want 10 servings. Yeah. So that means you also need x plus y plus z equals 10 total servings. That's the one part that's missing. Which means 1, 1, 1, 10. Does that make sense? Now it's good. So in other words, the matrix we want, this one's tricky, is 1, 1, 1, 10, and then the 100, 130, 120, 2190, 780, 670, 610, 13080, and 796, 136. So I had to multiply those numbers by 10, and that top one means total number of servings, right? Because we want to say how many chicken noodles plus how many chicken and rice plus how many chicken rotini to be 10 total servings. We're going to say like 2 cups of this and 3 cups of that and 5 cups of this one or something. Is that working? I'm still not 100% sure. Is that coming out? What'd you get? Derek, right, Derek?
Oh, I actually did this on that.
Oh, okay. It just makes it. Can I do it real quick? Let me try it. So it's what? It's a 4 by 4, isn't it?
Try it again.
What's that number 620? Oh, that's 670. Yeah, I got to write that a little better. That's a 670 here. I'm just getting the identity matrix. Am I doing something crazy? Well, I'm not doing, what am I doing wrong in this problem? Okay, 10 servings of soup, each of which, to produce 10 servings of soup, each of which, 10 servings of soup, each of which is 219 calories. All right, so if there's 219 calories, then there's 2190 total. Right, no, that's right. And X plus Y plus Z is 10. Yeah, that's good. Sodium, protein, yeah, that all looks good to me. Yeah. Sorry, guys. Right, but anyway, cut this one out. And then it should work. So.
If you cut it out, I ended up getting 0.7, 0.5, and 0.7.
7.5.7. That's what you got? I'll try it real quick. Matrix. Edit A. So then it'll be a 3x4. And it'll be 100, 130. Anybody else get that answer?
I got 757.
Oh, it's because I added zeros to all the numbers on the left here to X, Y, and Z.
757. Yeah, so 757. There we go. So it's 757. Yeah. What are they meaning by servings? Anyway, I don't got time. I don't know what they're meaning by servings. I got to go on to other problems. I can look at that later. If you're interested, office hours. I'm not sure. They're playing something funny with the servings there. There we go. So they're going to say, find the size. What's the size of that matrix? Is it a 3x2 or a 2x3? That matters. Remember, it's down first. It's down first, then across. So that's a 2x3. Yeah. It's the opposite of graphing. How you got to go down first, then across. Good. Then they're going to ask, is it a square, column, or row matrix? Square, means square. It's not a square. Square means, same, even, same length equals width. But a column matrix is just one column. And a row matrix is just one row. And this one is none. This one's not square, right? This matrix is not square because it's wider than it is tall. But it's not just one column and it's not just one row. It's none of those. Finally, give the additive inverse of the matrix. What that means is change all the signs. That's fancy talk. Additive inverse is this will be a super simple section for you. Additive inverse is just change all signs. So make it +2, 0 is just 0. +2, +8, +1, and -4. Done. Just change all the signs. All right, well, I'm out of time. So I'm going to stop there. So only 6.4 is going to be next time, and the sub is going to have to do the other ones. It's all graphing calculator with you. I won't see you next week. I'll be back. There'll be a sub here, but I'll be back the following Tuesday to hear that everything went beautifully with the sub.
Yeah.
And